In this video, we're going to look at the double angle formulas. So if you think about the original compound angle formula, sine of brackets a plus b, it was equal to sine of a cos of b plus cos of a sine of b. Now, if you let a and b both be equal to theta, then instead this a plus b will become theta plus theta, or 2 theta, and this will become sine of theta, cos of theta, plus cos of theta, sine of theta. So this term and this term will be the same. So what you actually end up with is 2 sine theta cos theta. You can do the same thing with your cos formula. So your cos formula, remember it was cos of a cos of b, so that will become cos theta, or cos squared theta. And then it was minus of sine a sine b, so it will become sine theta times sine theta, which was sine squared theta. Now the cos one, the sine double angle, is dead easy because there's only one way to write it, but this one, you could write this one differently. So I'm going to give the two formulas and explain where they come from. So this could be written as 2 cos squared theta minus 1, and this one, or it could be written as 1 minus 2 sine squared theta. So how we got this one was by writing your sine squared was equal to 1 minus cos squared, and the same idea for this one, you got this one by writing your cos squared theta was equal to 1 minus sine squared theta. So really you have this one formula, but from it you can get two more formulas as well, so 3 formulas in total. Okay, I've completely forgotten my tan formula, so I'm just going to write it down here. Tan of a plus b was equal to tan of a plus tan of b, all divided by 1 minus tan of a tan of b. Now, if you imagine we do the same thing, we replace both our a and our b with theta, what you'll have on the top line is tan theta plus tan theta, which is the same as 2 tan theta, and the bottom line is going to be 1 minus tan theta times tan theta, which is the same as tan squared theta. That's it. Okay, so there's just a wee summary. Those written out neatly. There's the formulas that you're given. They're the double angle formulas, and these are not provided in the new formula booklet, so you really must learn those. So very, very important. So very easy to learn, and as well, you have got them in a way, because remember what you are given in the formula booklet. You're given like sine of a plus or minus b is equal to sine of a cos of b plus minus cos of a sine of b. So remember, as long as you know how to do it, you can get from the original formula to these double angle formulas. So remember, you just put sine and a as both a and b as both theta, and you can jump to your new formula. So that's how you can get them. Okay, let's go on and look at these examples. So example 1 says, using the double angle formula, evaluate, and we've got to go from here. So using double angle formula, evaluate 2 sine 45 cos 45. Now this thing is dead easy. That is the same as 2 sine 45 cos 45 is the same as just sine of 2 times 45, which is the same as sine of 90, and sine of 90 we know and love as 1. Okay, this one, this is the same. That looks very much like 2 cos squared theta minus 1. So that's the same as cos of 2 theta. So cos of 2 times 75, which is cos of 150. And cos of 150 is minus root 3 over 2. This next example, it says eliminate theta from the equation. X is equal to cos 2 theta, y is equal to sec theta. Now we haven't really looked at this. We'll be looking at this in the next series of videos, which is parametric form. But there's no reason not to do it at this stage when we're on our trig. So we're just going to look at our x. X is equal to cos 2 theta, and my y, I'm not going to write it out, but y is equal to sec theta. Sec theta is the same as 1 over cos theta. Now, if I write out my x, there's three different ways I could write out my x. I could write it as, because it's cos 2 theta, I could write it as cos squared theta minus sine squared. I could write it as 2 cos squared minus 1, and I could write it as 1 minus 2 cos squared. I'm going to use a second way of doing it, 2 cos squared theta minus 1. Now the reason I've done that is because my y is completely in terms of cos. So if I've got my y, I could write cos in terms of y. So here, from this bit, I'm just going to say, therefore, that means cos theta is going to be equal to 1 over y. So my x will then rewrite our x. X then is going to be equal to 2 times 1 over y, and that's squared minus 1. So x is equal to 2 over y squared minus 1. And you might not like that, might not appeal to you. So what you could do is bring the 1 across. Bring the 1 across, so you have x plus 1 is equal to 2 over y squared. And then you could multiply across by the y, and we'll just go up here again. And y squared is going to be equal to then 2 over x plus 1 may look a wee bit nicer for you, but to be honest, they're pretty ugly no matter what way you write it. Okay, final example uses the double angle formulas in these solving trig equation. So what I'm going to do, I've got this thing, I have to change it, and again I've got three ways I could change my cos 2 theta. It could be cos squared minus sine squared, it could be 2 cos squared minus 1, or, and importantly in this case, it could be 1 minus 2 sine squared. The reason I'm going to use it this way is it gives this whole expression will then be in terms of sine, which will save me a lot of time. So we'll say, we're just going to put a wee asterisk and say, make all sines, S-I-N-E-S. So then they're all in terms of sine, so it's going to be 3 upon 1 minus 2 sine squared theta minus sine theta plus 2 is equal to 0, which is going to be 3 minus 6 sine squared theta minus sine theta plus 2 is equal to 0. So 0 is equal to 6 sine squared theta plus sine theta plus 5. Oh, that should be a minus 5. Let's get rid of that. That's going to be minus 5. So we have our sum is equal to 1. Our product is equal to minus 30. So our two numbers, when you go through that, are going to be 6 and minus 5. So we'll rewrite this whole thing. 0 is equal to 6 sine squared theta plus 6 sine theta minus 5 sine, then minus 5. And for the first two terms, I can take a 6 sine theta outside a bracket, leaving me sine theta plus 1, then minus 5 upon sine theta plus 1. So 0 is equal to sine theta plus 1 upon 6 sine theta minus 5, which means in this, for the first bracket, put it equal to 0, you get sine theta is equal to minus 1. Second bracket, you're going to get sine theta is equal to 5 over 6. Okay, we'll continue this on up here. First thing I had was sine theta is equal to minus 1. I'm going to do a cast diagram on down here because I'll have to do it later on for my other question, my other part of the other solution, I should say. Sine is equal to 1 at 90 degrees. So it's going to be equal to minus 1 in the opposite place, which is down here, which would be minus 90. But in our range, it's not going to be minus 90, it's going to be 270. So here, sine theta equals minus 1 means theta is equal to 270 degrees. The other solution we had was sine theta is equal to 5 over 6. You've just got to do your basic angle thing. So shift sine or sine to minus 1, and I got 56.4 degrees. So sine is positive in the A quadrant, so mark in your angle 56.4 degrees, and it's positive in the B quadrant, and that's 56.4 degrees. And there's where your two angles will be. So your final answer, theta, is going to be equal to 56.4 degrees. 180 minus 56 is going to be 123.6 degrees. And the last one, what have I said the last one was? Oh, minus 270 degrees. And that's it. Okay, you're now ready to do topic 5, its section of the Trig B section, and exercise 2, and questions 1 to 8.